To best understand how controls regulate the operation of a Horton fan clutch, you must have a basic knowledge of how all the components of a control system function. At the heart of every control system is the Horton three-way solenoid valve. The solenoid valve has 3 ports, allowing it to be plumbed 2 ways, normally open and normally closed. Here, the valve is plumbed for normally open operation. Air enters the end port of the valve via the air filter. Inside the valve, the plunger is surrounded by an electromagnet. Without electricity, the magnet is de-energized and the plunger is held against the lower seat. This opens the upper seat and allows the air supply to flow through the valve into the clutch. With electricity, the magnet in the solenoid valve is energized and pulls the plunger upward, blocking the air supply at the upper seat. As the plunger is lifted, air in the line is allowed to exhaust through the lower seat, disengaging the clutch. Now we'll plumb the three-way solenoid valve to operate in the normally closed mode. In the normally closed mode, air enters the side port of the three-way solenoid valve via the air filter. When no electricity is applied and the electromagnet is de-energized, the plunger is held against the lower seat and airflow to the clutch is blocked. Once again, due to the movement of the plunger, the clutch is allowed to exhaust its air through the opposite port, in this case, the upper seat. When electricity is applied, the electromagnet pulls the plunger up, blocking the upper seat and allowing air to flow to the clutch through the lower seat. As you can see, the Horton three-way solenoid valve filter assembly manages the operation of the Horton fan clutches practically by itself. So when we speak of controls, we're really talking about controlling the operation of the three-way valve. A basic control system consists of a thermal switch and a freon pressure switch. Just like the three-way valve filter assembly, an electrical control system can be designated either normally open or normally closed, depending on the type of controls or switches that are used. In a normally open electrical control system, all the switches will be open or off in their normal or resting state. This is a state at which the engine temperature is below the thermal switch setting and the air conditioner's freon pressure is lower than the freon pressure switch setting. A normally closed electrical control system is just the opposite. The switches will be closed or on in their normal or resting state. The most important thing to remember is that you must use a normally closed three-way solenoid valve filter assembly with a normally open electrical control system and a normally open three-way valve filter assembly with a normally closed control system. This is easy to remember when you understand how the proper wiring of the controls or switches creates a logic state. In this normally closed electric control system, we want the logic state of the switches to indicate if either switch is opened. To do this, a series connection is used. Electricity runs from the accessory or ignition terminal into the plus terminal on the thermal switch, out of the other thermal switch terminal, and into one of the terminals on the freon pressure switch, out of the other freon pressure switch terminal, and to the three-way valve lead wire. The other three-way valve wire is grounded. Remember, a normally closed electrical control system is used to control a normally open three-way valve, and the electricity passing through the closed electrical circuit holds the three-way valve in its energized or closed state. The fan clutch is disengaged. If engine temperature rises above the thermal switch setting, or the air conditioner's freon pressure exceeds that of the freon pressure switch setting, the series circuit will be broken or open. No electricity flows to the three-way valve, allowing it to return to its de-energized or normally open state. Air flows through the valve filter assembly to the fan clutch, and the fan clutch is engaged. Optional controls can be added to this series circuit. To install a manual switch, for example, insert the switch into the series chain so that electricity must flow through the switch when the switch is closed, just like the other controls. Remember the logic here. Any switch that opens breaks the flow of electricity through the entire control circuit. Now, with the addition of the manual switch to this normally closed electrical control system, the on or closed position of the switch is the automatic mode, and the off position is for manual engagement of the fan clutch. In a normally open electric control system, we want the logic state of the circuit to indicate if a switch is closed. Normally open electric control systems are wired as a parallel circuit. A parallel circuit is made by connecting the positive terminals of all the switches to the ignition terminal and connecting all of the negative switch terminals to the lead wire on the three-way solenoid valve. Now let's trace the logic as we operate the circuit. With the engine running at a temperature below that of the thermal switch setting and the air conditioner's freon pressure below the setting of the freon pressure switch, all the switches are in their open or off position. The electrical circuit is therefore open, and no electricity is sent to the three-way solenoid valve. The normally closed three-way solenoid valve, remember a normally closed three-way valve for a normally open electrical control system, and vice versa, is de-energized and remains in its normal or closed state. The air supply to the fan clutch is stopped, and the clutch is disengaged. When we look at the parallel and series circuits side by side, we see that the parallel circuit has more wires. It's this redundancy in wiring that allows each normally open switch in the circuit to send electricity directly to the three-way solenoid valve. Now, with the engine running, if the engine temperature is higher than the setting on the thermal switch, or the freon pressure is at a higher level than that set on the pressure switch, electricity is passed through the circuit to the three-way valve. The normally closed three-way valve is energized and held in its open position, allowing the air supply to reach the fan clutch. The fan clutch is engaged. As with the normally closed or series electrical control system, optional switches can be added. Always remember the logic of the parallel circuit. The switches are all normally open, and the closing of either one must complete a circuit. Now, to add a manual switch, make sure that one of the switch contacts is connected to the ignition and the other is connected to the three-way solenoid valve lead wire. Like the other switches in the normally open control system, the on or off position of the manual switch is for automatic operation. Can you see how in the normally open control system, a switch is never dependent on any other switch for completing a circuit to energize the three-way solenoid valve? You should now have a thorough understanding of how controls and the Horton three-way solenoid valve filter assembly regulate the operation of a Horton fan clutch. For three-way valve and thermal switch part numbers, refer to the Horton product line catalog. Through your understanding of the circuit logic used by these controls, and by following the basic rules presented in this program, you will be able to perform efficient and effective installation and service of Horton fan clutch control systems. Horton. For more information, see your Horton dealer or distributor, or call 800-621-1320.